Just before you start, perfect. Yeah, just before you start, Oluyemi, I want to say on behalf of the SCA, thank you so much for doing this Lunch and Learn. I'm so excited. I mean, before this presentation started, we were talking a little bit about the jargon topic. So, for example, I'm not going to do you a disservice by even talking about what this talk is about because I might get it wrong. But I'm really excited to hear, what you have to say. I actually did a little AI search about the certain terms that you're using, and I sort of feel like I vaguely understand, but I'm really excited to hear it from you. So, yeah, thank you so much, and thank you to everyone for joining. And I will just hand over there.
Okay, cool. Thanks. I'll just share my screen to begin with. Oh, I need to send a request. So,
Sorry, Zoom is more complicated than it should be.
yeah, I think it's just some sort of update to Zoom lately.
Yeah, I agree totally. Oh, there we go. Perfect.
So, slideshow. Okay, thank you everyone for joining today, for making it time for to just go through this lovely topic. This is one of those topics that over time in my career, I've actually found it very interesting to break it down properly and then to ensure that people understand the differences between these architectures from monolith to microservices. Having this clear understanding of why you need to, or even if you still need to just stick to what you have, maintain your monolith architecture. People need to understand when to make that move. And then if you eventually want to make that move, you then need to plan properly. There are a whole lot of strategies to kind of approach that. There are different means and things that you need to think about, a lot of considerations. And sometimes I've had to learn this the hard way as a software engineer myself. I've been part of different teams. You've had cases where all of a sudden your application just become inaccessible online, right? And not because you've not structured it properly. It's just because the way it has been built, maybe you have more traffic dropping in, and then your server got to a point that it couldn't handle the traffic and then goes off. And one terrible thing about application is once you go live out there, you can't take a break. Irrespective of what your project might be, once people start visiting your site, you can tell them, sorry, we need to work on few things. We'll be back in 2 weeks' time. Reputation gone because nobody wants to come back for that. So planning all of this is actually quite critical to the success of your project. So today, on the agenda, even though I've spent time putting all the slides together, I totally forgot to put a slide together for agenda. So I'll just run through it in my head. So basically, we'll just take a look at what a monolith is, have an understanding of that as detailed as I can be. I'll try my best. And the same thing with microservices too as well. Understand what microservices is. And preparing for these, I had few demos that kind of shows because I'll be sharing the code. So I might be switching between slides to the code base just to show us a few things. It's not going to be entirely complex. I'm just going to mention this and this at the way this app communicates. So with that, we can actually have some clear understanding. So I will share between that. And also, I'm going to run different apps. I have an application built to explain monoliths. Then I have a couple of microservices, which were more like breaking down the monolith to different services. So I will just show that too as well. So who am I? My name is Oluyemi Olususi. I think a lot of people just find it easier to stick with Oluyemi or just Yemi for short, and you can do that as well. I'm a senior software engineer. I've nearly a decade of experience. I initially started with just backend, down to getting introduction to what the look and feel of an entire application should be. So I tend to pride myself in the fact that I have a full understanding of software life cycle and I've had the opportunity to lead different teams to build scalable solutions, both in-house or manage remote teams of engineers. I'm a volunteer here at the STA. I currently lead the dev team for one of the lovely project that STA is working on. I think over time, once we're done with that, we're going to share that. It's still in progress. I'm a fitness enthusiast. Really love, just starting the day strong or going later in the evening just to get a better sleep at night. I love football. And in addition to that, I love music. I feel music is just a universal language. I don't know if everyone feels the same way, but generally, I don't care what language is, for as long as the rhythm kind of fitting into what I'm working on at the moment or just the way I feel, I can just move to any tune. Okay, let's get to the reason why we're here. Understanding monolithic architecture. So from the definition just on this slide, it's just a single code base where all components of applications are just tightly coupled. Just to expand on that is where you have an app being built simply just for a specific feature, for a specific purpose. You can have an e-commerce platform. It's basically to list your product, and then at the end of the day, people come to that, view the product, and then eventually have to cart. And hopefully they come back again, if they like your product. So building all of this application in one single component where you have a specific module handling things like registration, logging in, reset your password or request for a password link, or even confirm the password. All of these are tightly coupled as a single unit, as a single code base, and then deploy together. So that's how it works. They share the same things like database, where you manage the data of the users, for users logging in, providing their details, or for your product to list your product. They sit somewhere in the database. So all of these are just tied together in one single component. This is not entirely bad. I think it just comes with a whole lot of benefits too as well, as much as some sort of disadvantages that if you're not handling them properly, it could be a problem later on. But just with that, I think we get the picture. Can I see if you just nod like you understand like having single component? Cool. Thank you. And like I said, it's not entirely bad. You have a monolithic application, and most startups, every company tend to start with this. You start with just having your code base together. It's more like an early state thing. It's simple, it's faster to start with, and it doesn't have a lot of dependencies. So simplicity, you can have one developer or one software engineer to start building this because it's that simple, right? They could start putting it together. And then when you have more funds or when your team start to grow or when there's a need for that to expand or the growth, maybe you get more funds. And then with that means you have to do more marketing. And then it means you get more customers. And in a way, that's more traction. I mean, more profit. So making those profit means you then need to extend. So for now, it's just a way to kind of start. You easily build and deploy that small project. And then you can get your MVP straight to the market. It's easier that way. Like I said, MVP is just like minimum viable product. This is your product offering, and then people can actually still use your product. But most customers don't even care if this is available. Like you can go to Netflix now. I mean, maybe you're trying to stream a video and then you're concerned about how this video is being rendered. As a matter of fact, it just feels like it's none of my business. I just need to see a movie, right? And they just log in. So all of these are handled differently. So monolithic, just a single code base that does all of that. It's easier to start with. And you don't need to start thinking about complexity of separating your services into different projects because then you will have to start thinking of how they communicate with each other. It's a lot of work. It's one of the benefits of just starting with monolithic. And but what happens when as this application grows? I'll give you a specific example of, Black Friday for an e-commerce platform. It's always exciting. Everyone just wants to chop. Like you're just waiting for that day to come. And as a matter of fact, engineers, product owners, project managers, everyone has actually put in a lot of work to ensure that they are ready for that day. Imagine if the site goes down on that day. I mean, there could be some sort of redemption and say, maybe Cyber Mondays, another opportunity as well. But then if it happens again, the company and maybe software engineers involved might start to rethink what their career looks like. Because if your site keeps going down consistently, then it becomes a problem. So this is some of the challenges. We'll just go through some of those challenges in a bit. So one of them, the major growing pain is deployment. Just so I can show you guys what running a monolithic app look like, I will just switch to the code base for Monolith app. I will attempt to run this.
Oluyemi as well, I should mention that I've said for people to pop their questions in the chat. And I'm
Perfect.
just, yeah, maybe for the end. And I'm just mentioning that because I'm just about to type a question and I don't want you to answer it immediately. It's for
Okay.
it's for later.
Yeah, that makes sense. That works.
Cool.
Okay. This is taking time. Anyways, while we're waiting for that to run, I'm just going to show the. This is what the structure will look like when it comes to a monolithic app. This is the entry point for the application itself, and you see you have different routes being defined. Like I mentioned, you can have different endpoint. For example, someone is going to log in, someone is going to validate their, or maybe get authenticated or view product. Each of these handler tend to handle some of those different functionalities. And then as it happens, you have functions that then handle them and return response. So you just have everything bonded together in a single code base entirely. If this is running now, yeah. So I can easily just show us. This is just as simple as it can be. This is not what an e-commerce looks like. But I just wanted to render something and you can click to fetch a product. This will make a call, fetch a couple of products, laptop price. If this were an ideal e-commerce platform, you will see all of those listed with amount. And now this with the code base, what it looks like is everything is just in the same structure. You can see the directory, the folder is just monolithic app. It's just that. And then you have different endpoint handled by different functions. Okay. So what happens is if we need to make any deployment for any single change, if, for example, I decided to make some changes to this get product handler, and then instead of just 1,200, I decided to make this 1,500, for example, I can't independently deploy the product or catalog example. I will have to deploy the entire application all over again. This is one of the pain. It's just so difficult to be able to deploy an entire. And if, for example, this breaks and then someone make a mistake because we are human, right? And sometimes mistake happens even with deployment. If I make any mistake, for example, and then decide to run the app again, if I maybe break something here intentionally, and then attempt to run this app again, it's not going to run because it's an error. And then if this has been deployed to an environment, your app will go off because it's difficult to track it. Someone just submitted a pull request, added a couple of features or changes, and during that process, they mistakenly broke or introduced a bug. Then you'll have to look for that and fix it. But before the time understanding what happened to when users visit your site, because users are not entirely patient, they just want something very fast. So if you go there and then it's down, you bounce and go to a different competitor entirely. And also scalability. For being able to scale your app, you have to scale everything all together. And scaling app, I think scalability is just a term used to say if I'm getting more tractions. with people viewing product, that means there's more traction on product. People just want to view product. On a day like Black Friday or Cyber Monday, you're not expecting, I mean, you should expect that you have a lot of returning customers. So it's not like they're registering newly. Some of it are just coming back to log in, but there'll be more tractions with product. People want to view product, meaning you could have 1,000 users within 30 seconds, trying to retrieve list of product. And if there's a bottleneck, this can actually crash the app because you can't scale the product service separately. You will have to scale the entire app. And then what is common with monolithic, it's being able to scale vertically, meaning that if you have a specific, like a RAM or CPU, then you'll have to throw in more machines so that it can handle some of those traffic. So it's difficult to actually scale and also really circle because all of this code are actually depend on each other. You will have to wait for someone who is working on, say, product listing, for example, and then someone who is trying to fix a bug with user authentication or registration. At this point, you will have to wait for all of them to be done before you can then release the entire feature. So this slows down. If this were separated into different services, as we will see very soon, it's easier for you to just easily work on products, deploy that, work on user authentication, and then deploy that. That way you have a very fast and then rapid release cycle rather than just waiting for everything to be done before deploying. Those are some of the pain, but as you guess, it's the solution is just breaking things down into microservices. A very good question here. Why microservices? But I hope I've been able to just, build on what we have as monoliths to for us to transition into this. Basically, at the point where you've started noticing that your team are growing, you're having more software engineers to even begin with, because you don't want to attempt breaking down into microservices with just a single developer, right? Every successful product now, from Facebook to Twitter to Netflix, mostly start with just one single engineer or two, right? And then later on, the team expands and they will have to start building more because that means they have more resources. So microservices brings kind of build on some of the disadvantages of monoliths, faster deployment. I gave an hint earlier, if you're working on product service, as soon as you're done with that, you can easily just deploy that. You don't have to wait for someone who is working on the user authentication or someone who is working on the shopping cart or working on the checkout services. You can easily deploy and then you can scale individually too as well. Scale each of the features, product catalog, or just checkout. And for flexibility, this is also very important. Software engineers tend to have bias, mindset, or will I say preference for some programming language. For example, I tend to use a couple of programming language, but things like Python or Java, it's not on my list. I use Golang, JavaScript, and I do a lot of TypeScript as well. Now, if I'm joining a company, I might actually want to start writing Golang. I might actually want to learn Java. But what if I can transfer my skills of using Golang? That will make me more productive. So with flexibility, you can choose the right tech stack for each service. Now, having each services separated means you can build them with different programming language, and then you won't have to worry about how all of them communicate because the focus will be on setting a generic communication pattern that everyone can actually work with. Okay. I think with all of this explanation, sounds more like, oh, microservices sound simple, but of course, moving is not something that you can just jump into. What makes it hard? I think one of the major thing is organization resistance. To some extent, when something is working, you don't want to touch it. Let's leave it, right? You will have to find a way to understand. I mean, sometimes I've actually expressed this firsthand. It takes a lot of conviction and documentations and report writing and forecasts to convince companies sometimes to say, we need to move to microservices because some will have to learn the hard way, on a day like Black Friday when your site goes down. At that point, it becomes inevitable. But it's your job as a software engineer to ensure that it doesn't get to there. You need to then be able to identify and feel like, hey, boss, if we don't do this now, we're going to run into problem. So being able to understand that, then you can actually, go over that organization resistance and communication overhead. With this, I showed us earlier what the monolithic app look like, and I'm going to show it again. Fix this back. Oh, good. And when we look at this particular function, I'll just zoom in a bit. All of these are more like different routes that if someone is trying to check out, it can go to like www.yourdomain/checkout. And then this is being handled by a specific function. This is handled by checkout. Don't mind all of this. They are not specific logic. They're just a way to demo what we're doing today. By the end of the day, these are function calls. But when you break this down into microservices, it becomes an API endpoint. So API endpoint is just a fancy word to say, instead of having this communicate within the same application, I'm going to call a specific service. API is application programming interface, which is just a way for different services to communicate with each other. So instead of just calling checkout here and calling this function, we're going to be calling a specific service. And while we're here, before we move to splitting or even further, I will show us what the microservices look like, taking a look at what we have as Monolith at the moment and how it's been separated into microservices, just to show us the code base. But I think my talk was to get to that. So I have all the microservices in a particular folder. So what I've done is to name them intuitively. We have checkout service. We have email notification service, product catalog service, and the user authentication service. Now, all of these are just a representation of what we have with monoliths, where we have validation. This will actually go to more like user service. And this is products. We will go to product catalog service, and cart and checkout will go to checkout service. And then, being able to send email will then go to email service. That's just a little bit of intro there, but we'll get to that. I will expand on that later. Also, one of the major issues is database splitting. When you have a monolith app, you have all your database in one single database. It can grow to become very gigantic that it might be so difficult to handle and manage. But then you need to start breaking them down. So rather than using a centralized database, you then split them into separate, small, manageable database. So I can have a single database for users, have a database for product, a separate database for adding to carts, and then even things like tracking checkout and then confirming if it's someone that successfully checked out or not. So splitting all of those out makes it hard, but you need to then understand how you can systematically just move from one step to another. So breaking it down, where do you start? So identifying the boundaries of the service, identify where should we separate first. So you take a look at your monolith and then you understand that people come in to register, they log in, change their password. All of these can actually be categorized as a user service. So you break them down and then you try to separate that first. Further down the slide, I'm going to show us that you don't need to like take a jump or just take that step of moving entirely from monolith to microservice. Oh, we've just been motivated. Let's do this. And then you move all over. No, it has to be more like systematically do one first, then understand what other service can you separate again, and then do that afterwards. So for example, you can start with user service, build another service, checkout service, catalog service, and then notification service. All of these are what you've actually extracted from the monolith. So in a way, it's going to make your monolith lean, and eventually you actually can actually retire the monolith because it will be redundant and irrelevant. But you just take this step to understand what are your business requirement and then what can I separate? Because you can't start separating each of your code or each of the folder without having a proper understanding of what your business requirements are and a deep understanding of the product itself. So this is what it looks like when you break it down. Like you have checkout service on its own. If I just take us back to what we have with Monolith, you just have everything. You have checkout, catalog, notification, and a single monolith. But then when you look at what we have with microservices, we then break everything down. So this is a project on its own. Catalog is a project on its own. Notification is a project on its own. All of them are kind of separated. And then they are still dependent on each other, but they are loosely coupled. It's not like it's so tight that if service notification service is down, the entire app crashed. Like I showed us earlier, I intentionally just introduced a bug and you notice that we couldn't even run the app again. For microservices, if there's an issue with notification service, you can still go to a platform, e-commerce, for example, you can still log in, you can view product, you can check out. The only problem is you might not get an email. I think this is also relatable. Sometimes you've actually signed up or carry out a specific product steps on a platform and you realize that you were not notified. It's not because it wasn't working, right? It's just because the service was down at that point. But you were still able to carry out those steps. You were still able to add to cart, build the product. That's one of the benefits of microservices. All right, so what does success looks like? Now I'm going to show us again the code base for this microservice. You will agree with me that now we have everything separated. We have user service on its own, product, authentication, and email notification, just separated. At the point when you start considering, oh, this is very successful, is you have independent service that doesn't depend on each other. Like each service kind of operates independently within its own domain. So they still communicate, via API. I think I'll show us the endpoint for, I'll show us this. We have handler. Now this handler, this is coming from the checkout service. And you can see we have two different endpoints, cart and checkout. And if we go back to the monolith again, we have cart and checkout. So what we've just done is take this out, separate it into its own service. So the API, this microservice for checkout is responsible for this. So this way you're breaking things down gradually. You're taking that step from monoliths to microservices. So when they're separated like that, communication is going to be via API and efficient communication. So it easier for you to then set up communication mechanism. Easier is actually, I think easy is relative here, but when you actually start using it, then you'll be able to set up a proper way to ensure communication within all your services. And of course, scalability and release resilience. When you break into microservices, and if we go further, there is some sort of advanced concept that I think it's not covered, it's not in the scope for this talk, but later on, you can easily retry, introduce things like retry logic in case you have more traffic and then your service is down. You could set up configurations to ensure that if a service is down, something needs to restart it, before your users get an error message or get thrown and say, you know what, you can try again. Something is actually retrying at the back end before showing them further steps. And of course, for faster deployment, development cycle, I think we touched on this a bit earlier. I explained about this database earlier, but I think this graphic, this visual will actually, bring this to life more. You have a gigantic database, and then you kind of employ the database per service strategy. So you have user service database separately, catalog service DB, notifications, and cat service. All of them kind of have their own separate database. That way, it's more manageable, but then that means you need more resources, you need more team members because just one person cannot entirely manage all of this. And very important is how to communicate between the services. The communication pattern in microservices are basically two. You can have synchronous communication or async communication. So for synchronous, it's just you wait for response. So if you make a call, you wait for response before you can do something else. That is easier to get started with, and that is just being used by that kind of use REST API. It's an architectural style where you have different endpoint defined. So if I need to add to cart, I make a call to the API with an endpoint of slash cart. I have to wait for the response to be back before I can then proceed. So that's synchronous. But async is asynchronous communication is you don't need to wait. This is where you use things like message brokers. Some of them are Kafka and RabbitMQ. Basically, what this does is they have more like a queuing system, first in, first out. So you send a request in, it stays in there, but then it doesn't stop the communication from going on. This is more common with things like email service. If you're sending more like a newsletter, for example, or you have multiple users using your platform and you don't want them to be blocked by notifications, you can queue that up somewhere. And then after a while, the service keep running and then send those email sequentially, just the way they are being inputted into the broker. So synchronous communication via REST API, which is what I've just shown in this demo in the code base. And async, if you are taking it a little bit advanced to using Kafka or RabbitMQ. I've just decided to, mention some of those tool layers. So in case anyone want to, take it further to request or just do some inquiry and find out more about. So step by step, putting everything together, identifying the components that you need, like we extracted user service, product catalog service, you need to identify them first. Once you identify, then you build the service, implement the new service in a different folder directory. And then once you're done, redirect traffic to that. So if someone is logging in, and I know that I've already separated my user service from the monolith, instead of allowing them to stick to the monolith structure, I redirect them to the microservice that I built for user. And then gradually you test that over time. If you notice that there are no errors, of course, if there are errors, you can track that and then you can get feedback easily. And after redirecting traffic, you know that, oh, okay, right, this is going on well. You've decoupled related services. And then you repeat the entire process. Even before retiring of monolith, you go back to this beginning again, identify another component that you need to build the service, redirect traffic to it. Now you're testing. You could start with just one, two, and then three services, and you notice that you're good. At the point where you know that you've separated all your service, and customers coming to your platform won't be hanged because they actually want to do something with your product. So you can retire the entire monolith because this way you've actually got it right with your entire microservices structure. A couple of lessons from the feed. This is something that has been very helpful even for organizations that I've worked with. And then even while working on microservices myself is automating a lot of things. One of them is your testing. This is one of the best practices, that every software engineer needs to have, or you need to keep working on, even if you're not at the moment, is writing unit tests to be able to test some of your implementations. And then once you do that, you don't have to run it because your project can really get complex. You don't have to run the entire test manually yourself or go to the page and start clicking to test how it works. I click here. Oh, I can set this one. I click here. You can automate this entire process. And then also you can do things like CI/CD pipeline, which is continuous integrations and continuous deployment. Again, that's just a fancy word to say I built this feature. I want to make sure that if I deploy this and then we add it to our existing project, it doesn't break the features, existing features. So if I've just introduced something new, maybe my manager walk up to me and say, can we add an option of buy now, pay later, or just introduce receiving payment by Bitcoin? That's a feature on its own. But I have to make sure that by the time I'm integrating this new feature to my existing project, it doesn't break the current payment structure because even if the initial one was still okay, people were still happy to use it. But you just want more, give them more options. So don't give them more features and then break what was working before. And this is what CI/CD does for you. Try to ensure that every of your process um, is less error prone. For observability, it's being able to log. Now, when you've broken everything down into different services, it can really get nasty when something happens and you don't know where it's coming from. Because your microservices, take a look at companies like Netflix or Google or even Monzo. These companies have tons of microservices, close to 1,000, 2. Now, it's difficult to start tracking where issues are from if you're not logging and monitoring. Because when you log and there's an issue, you can easily go to your log and track which service is responsible or which service does this error originate from. Then once you know that, it's easier for you to go to the service, check your code, check the error message, check the status code, and then eventually fix it. And for ownership as well, you could have, if you've ever been in an environment where, I mean, large teams, large corporations, you have teams who are, for example, Gmail, Google, there are teams just working on Gmail only. I mean, Google have tons of service. There are teams that their only task responsibility is to work on Gmail. Now, Gmail even has more features. So there are teams whose the responsibility is just to work on your inbox or draft or send message. So you can see these things are broken down. All of them are working on different services, even though they're working with the same team. I've been in a company where I had no idea what number of services that, I mean, I had an understanding of the services, but I've not seen the code base before. I can tell people, oh yeah, I work with Microsoft Azure, but I don't know what this part does or that part does or this one. So every team takes ownership of that specific service and then they can actually build on that because this way the attention is more focused on the service rather than just the holistic platform itself. So running microservices, you can easily run that with Docker Compose. If I just show us the code for the microservices for what I have here. This is Docker Compose, and the way it is structured to say, okay, for my user service, I want that to run on a specific port. For the email service, I want this on this port, similar, in the same vein for product catalog and then checkout service. All of these are running on different ports and running locally. And then here you have to do is just issue the command to be able to run that. So if I do Docker Compose up and then cross my finger, okay. So you can see just start running all of those services. You can see microservice portal catalog running on this port 8082, checkout service running on 8080, email service running on this. So all of those services are kind of running on their own. And I can even track the log as well. And even if I want to, I have a script here to be able to simulate users, but I'm being conscious of time. But basically, you can use this to run your services mostly for small scale microservices and locally. If you really want to go further advanced, that's when you start using a tool like Kubernetes. Kubernetes is also a tool. It's called more like it's an orchestration tool. Like when you have an orchestra and then you have different sections of those. There's someone who kind of anchors and control everyone's, right? He can tell this band or this team to, increase the volume or just reduce it. I mean, for those who are musically inclined, I'm sure you know what I'm talking about. But eventually, this kind of handles everything. So if your service is down, it introduces features like service discovery, retry logic automatically without you doing so much. So again, this is some advanced topic. I can spend a day just talking about Kubernetes. So I will advise that people can actually go further, just look into that too. When your microservices begins to grow and then you have more services. So scaling the team and not just the system. I think we touched on this already, but basically you decouple the team, you give them some sort of autonomy to be able to own those features, those services, and flexibility as well. This improves developer experience as well, really, because no one is stepping on each other's toes. You're working on your service. Gmail, someone is working on, I mean, a team is working on inbox, a team is working on draft. We're not waiting for you. You're not waiting for us. We're not dependent on each other. This is very good for developer experience. Um, like we're saying, transition is we have a monolith that was like this, a single code base, to separating them into different manageable services. Um, Common mistakes. Very important. Rushing into microservices is one of the things that I've seen in the industry, right? Because people get hyped and they feel like, oh wow, well, we've just heard about new architecture. Can we just start doing that? And then you rush into it without breaking things apart. I talked about those gradual steps that you need to take. If you don't understand your component and they start breaking them out, you can't just rush into microservices. Otherwise, it's going to be a problem. Poor service boundaries. So this is very tied to like your requirement. You need to understand your product. You need to understand your requirement. That way you can set clear boundaries. You can know that this belongs to user authentication service or this belongs to checkout service. And then you know how to separate those services and then eventually start working on each one. Over engineering, very common as well. When you start with microservices, it's easier to start thinking about, oh, message broker, Kafka. But why not start with REST APIs first, just a couple of endpoints, and then start with Docker Compose instead of just starting immediately with Kubernetes, except if you have, if you have the technical skills to do that, then you can go advanced. But at the point when you start migrating gradually, just don't over-engineer things. Just start simple, start small. And then, like I said, there can be tons of microservices, 1,000, 2,000. You need to be able to log for a distributed system because it's hard to track which service breaks, which one is actually buggy, which one do we need to look into and fix. So neglecting observability, it's a common mistake as well. Of course, inadequate communication. Like if a team is working on a feature, they need to be able to document properly. This is where you have tools like Jira and also Slack or every other communication channel to say, this is what we're working on. And what I've also noticed, even at work too as well, is you could have a day where all engineering teams kind of present what they're working on. And then that way you don't have to repeat the same thing, right? Someone must have been, it's more like duplication of effort, right? Someone is working on a feature already related to their service, and you're doing the same thing because you need that feature. So it's best for you to then reuse what they built rather than just re-engineering things. So communication is very key when it comes to microservices. So I think this is the last part, and it's a very important question. You need to understand, is it right for me? Think about your growth. Can your current system handle future demands? If you can't, then you need to move to microservices. An example of Black Friday or Cyber Monday. I keep using those examples because they're very important. If us on a day like that where you're expecting customers to come in, you're bound to make more money. And if it goes down, it's a problem. So when you know that you're growing and you know that you have more returning customers and you're expecting tractions, you should rethink how you do things. So you need to consider growth before upping on microservices. Think about timing. Do you have resources to transitions? Do you have enough software engineers? Are we properly documenting as we should? Do we have a proper structure for that? Do we have the funding, to grow and scale? And complexity as well. As you can imagine, with everything that I've talked about, there are complexity with tools, with structures, with how you build your project. So you need to think about complexity and see if it's something you can handle now or later. And of course, the business goal. Where do you see yourself? Facebook started as just sharing moment pictures, but now they've grown. I think at some point, I used to say this with friends, like Facebook got confused. They felt like we've gone beyond just face and this. They decided to change to Meta because they're confused of the features that they've been building. So you need to understand your business goal before you can start thinking of, extending and then building more services. Thank you. I think this is the end of the slide. So microservices, really they're about solving right problems at the right time. So the advice is take a step back and ask if it's the right move for your organization or not. Thank you guys for listening. I'll take questions.
Wow, thank you so much. That was absolutely brilliant. Just want to give you a free clap.
Thank you.
Like, honestly, I mean, yeah, I don't know what everyone else thought. Maybe they can't speak at the moment, but as someone that's not the most technical in the room, I really enjoyed that just because you really clearly explained, you know, the whole journey, and I especially loved the kind of walkthrough of the benefits of the transition, why you should do it, why you shouldn't, what to consider. So thank you so much. That's really, really interesting. Um, I've probably got the most questions up, but let's see if anyone else asked them. Um, so Onyeka asked, but he's gone.
Yeah.
Why don't most startups go for microservices ab initio? Is it costlier? You kind of mentioned that, I think.
Yeah.
Um,
I think I touched on that, and then he said,
yeah.
just answer my question. So,
I think that was a different one. It was, but yeah, I agree.
oh,
I think you mentioned that. Okay, let's see if you've mentioned any of the questions I've asked. Oh yeah, I'm quite interested in this. So, what I was asking, what makes one tech stack more suitable for a particular service than another? Because you mentioned that to do with microservices.
okay, yeah, that's a very good question. Sometimes some services, depends on what you're working on, required speed. And when you look at each programming language that we have, I mean, this is the reason why there are new programming language every time, because when you've actually stretched a particular language to its limit, and then you start thinking about, oh, this slows down when you're running concurrent or multiple 1,000 or 2,000 requests, and then you start comparing the metrics. This takes maybe more like 2 milliseconds, and then the other one take microseconds. Microseconds, it's faster, right? Programming language like C++ and Java, they are the OGs of programming language or big within stuffs. But then Google itself, I think the team at Google realized that they needed more speed and more structure. That was why they built Golang.
Mm.
So when you start thinking about tech stack and then you understand your component and different services, and then you realize that we need email service, especially we need emails and notifications to be faster. Right. If we have a whole lot of technical team, we'll probably want to use a tech stack or a programming language that will deliver that as fast as they want it to be. So each of those languages tend to have their own strengths and weaknesses as well. So when you introduce microservices and you have flexibility, you can then target each component and just use the right tool for the right job, understanding this will serve us better for the service than the other one.
Wow. Okay, so interesting. Thank you. Um, And then the only other question for me and anyone else, feel free to dive in, of course. But and this might be a bit like how long's a piece of string, but I was wondering how long could it take or does it maybe take to transfer from monolith to microservices?
So I will tie this to the scale. It could
Okay.
take from 6 months to 1 year, you know, depends on how complex the project might be. Because at that point, you still want to maintain your monolith. For example, if you've actually built a lot of users over time, and then you want to start gradually moving, there's a term that we use a lot. It's more like chaos testing. So, when you've identified a particular component and you separated that. So instead of directing traffic to your existing monolith, you're directing traffic to that new service. At that point, even while you're working on other services, identifying the component and separating it, you probably just want to keep testing that to ensure that it doesn't go down. So it can take a while. It can take,
Mm,
I mean, it depends from 3 months to 4 months to 1 year, and until you know you're ready. And then to be very reliable, you need to do a lot of testing, a lot of automated testing, a lot of manual testing, and then catch bugs. So to get to a point where you'll be very comfortable, from experience, I've seen services take more like 1 year to 1.5 years before you can actually complete migration from monolith to microservices.
wow. That is a
And I,
wee
I
while.
think I think it's worth mentioning that a lot of business requirements and gathering goes into that as well. Even if you understand the product, there's every possibility that not all the founding team members will still be there. So if you have new project owners, sorry, product owners or project
Mm,
managers or scrum masters, they probably need to also document so that they can share that, and then they need to take a look at their business requirements as well. So a lot goes into documentation, right? Even more than writing the code, because when your documentations are clear, you have a clear part, you know what you need to build, and then you can just, start writing code. People made that mistake a lot as well. They just feel like, oh yeah, we need to rebuild these or we need to extend to microservice. And then the software engineers just get down to the business and start writing the code and be like, oh no, we don't need that feature. Then you go back again
mm, mm,
and rewrite. So documentation is very important. So I think I just felt I
mm.
need to add that in.
Yeah, no, thank you. That's so interesting. Wow. It's a fascinating topic, and I can imagine you talking about this for hours, and I wouldn't lose interest. You're like, whoa, you've got the passion, the knowledge is great. Really brilliant. Thank you.
You're like,